All right, so I've been hinting at domain and range for a while. We talked about domain and range when it was is it a function, where we talked about the inputs are the domain and the outputs, what comes out is the range. The money you put into a vending machine is the domain. You might put a quarter in, you might put a dime in, you might use your debit card. What comes out is the type of food that you purchased. That's the range. So I really liked this visual because it kind of goes over those things again. Specifically, the domain is the set of all inputs. And if we look here, people think writing domain is hard. It's just whatever the X values are. That's it. Boom. The range are whatever the Y values are. Whether it's here in a mapping diagram or written as a function table or even as a set of coordinates. They all tell you the domain and the range. The first number is the domain, the second number is the range, and you just have to go down the list. Now, sometimes we have to look at it in terms of graphs. Here's the secret. If you have something like this, number one, where the line is continuous, then you're going to have these greater than or less than values. If you have it, and I'm just going to draw over here for this grid, if we have it like this, and we've done a question like this before, where there's just single dots and it's a discrete function, then you wouldn't have the continuous greater than or less than. It would look more like we see up here with distinct actual values. So let's take a look. What's the domain? The domain is, well, first of all, we know domain is the letter X. So immediately we know it's not number 4 and it's not number 2 because they have the letter Y. So now we have to say, okay, given that, here's my x-axis. Aren't they nice for writing the letter X for you? Oh my gosh. Here's my lowest X value. Here's my highest X value. I can tell my graphs are at that point. So it's number 1. That's it. Perfect. Let's jump over to number 3. Okay, first of all, again, it wants to know the word domain. Domain is always the X values. Think about the alphabet. X comes before Y. D in the word domain comes before R in the word range. So I know I'm not going to have number 2 or number 4 because those have Y's in it. So now we have to say, okay, well, what's my lowest X value? Here's my X axis. My lowest X value is right here. My highest X value is right here. So I just have to count. Well, the origin is at 0, so this is 0, 0. So that means that value is -1. Now we know what the answer is, choice 1. But let's count. Here's 1, 2, 3, 4, 5, and 6. So my answer is for sure number 1, -1 to 6. All right, let's go down here. Let's talk about domain and range for these problems. Here, notice how these have these arrows. Arrows are our friends. They almost always mean all real numbers. Here, because these arrows are going down and up, our domain will be all real numbers. I'm going to write the double R. Our range, what are our Y values are going to be? Also, all real numbers. Now, letter C, you're probably not going to see, but let's just to say it. Here, we do see the arrows. The arrows go continuously up and continuously down. So because of that, we know our range is going to be all real numbers. But the issue is that look at our lowest X. Here's our X axis, but it starts at 0. Then it keeps going up forever and ever. So in this case, our X are all values bigger than 0 because there isn't any graph for -2. Over here, there's a graph for -2x, like x equals -2, but not on this one. Let's look here. Here we have these arrows. These arrows consistently go up and they consistently go out. So our domain will be all real numbers. But our range, look at, here's our y-axis, it stops at 0. So our range is going to be all y values greater than or equal to 0. All right, let's do this last one, and then I'm going to teach you one more thing. Here, my arrows tell me that if I could zoom out forever and ever, eventually I would hit all of the x values. So my domain is going to be all real numbers. Almost always your domain will be all real numbers in algebra. In advanced algebra, maybe not, but in algebra, almost always the domain will be that. The range, well, our range for quadratics are dictated by our max or our min. In this case, we have a max at -4, -1. That's our vertex. That's our turning point and our max. So our highest that our y value could be would be -1. So I have all y, so I have all y values less than or equal to -1. Now, we just wrote it as inequalities. There's another way that you could write it. You could write it using interval notation. So all real numbers, super easy, -infinity to +infinity with curves, because infinity is limitless. Here, because it has 0 as the starting point, we would put 0 there. Because it's equal to 0, we put a hard bracket. And then it goes on forever. So we do infinity with a soft bracket. This is all reals, so we know anytime we see all reals, we have -infinity, +infinity. Here, again, we have all reals, so we have -infinity, +infinity. And then here it says, well, 0 is our starting point, and it's all the numbers above 0. So we have a hard bracket at 0, and because it's +infinity, we have the curve. If I'm going too fast, great. Pause the video, rewind, and watch it again. Here we have domain is all reals. Anytime we have all reals, we have -infinity, +infinity. And then notice how the y values are less than -1. So we're going to start with -infinity, and we're going to stop at -1. And that's why the infinity has to go on the left. All right, that is domain and range.